Are you in grade 9 this year?
Grade 7.
Grade 7. This is your classic, I have food and I'm buying food. So I want to model it with an algebraic expression for some reason. So I think the important thing right now is just turn the numbers into variables and then we can manipulate the expression afterwards. Or at least that's what I like to do. So the first thing that we know is each cupcake costs $1.50. So how much, and we're trying to figure out the total amount of money you spend. So how much money do you spend on cupcakes, or that you profit from cupcakes? $1.50 per cupcake times the number of cupcakes. So 1.50 times C. So now we have to count in the amount of money that we lost. So each cupcake takes 30 cents away from our profits because we have to spend that in materials. So we know minus 0.30 cent times C. And then for some reason also we lose $20 of profit per month, unfortunately, which is just minus another 20. So immediately I don't think any of these answers look like the answer that we have here, but the important thing to notice is that the distributive property in answer A, and I think if you try to factor out, I guess, the negative sign on this part, what you end up getting looks like 1.5 C minus 20 plus 0.3 C, which is the correct answer. Yeah. Anyone have any questions with that? Great. This one's exponent laws. It's not as complicated as it looks, I think. Have you guys learned exponent laws? If you want, I can write them up on the board. I think, to be honest, this is a question, we remember 3 was considered, the one we just did 2 slides ago was considered a high complexity question. This is not necessarily complex, but it takes a lot of time. If you guys are running out of time on a question and you see something that looks like that, I would probably recommend skipping it, because you know that you have to basically figure out the exponent on all 6 of these expressions to actually be able to figure out the answer. So I'll just walk through each of them one by one, because that's all you can really do. So the first one, 3 to the power of 4 to the power of 2. So we remember our exponent laws. When we have that second exponent outside the parentheses, like we see in 3 to the power of 4 to the power of 2, we can just multiply the 2 exponents, right? Because you can think of it as taking the inside and multiplying it and taking the exponent of it, which is all it is. And we know with multiplication of exponents of the same bases, remember these are the 2 bases, and obviously they're both 3, we can just add the exponents. And this is just 3 to the power of 8, which is equal to 3 to the power of 4 times 2, which is also greater than 3 to the power of 7. And I believe the question is asking which one's greater. Yeah. So we know we have 1. I'll just put a check mark on this one. Okay, so the next one. 3 to the power of 12 divided by 3 to the power of 4. So we use our exponent laws again. And remember, all of our exponent laws are just derived from multiplication, because exponentiation is just repeated multiplication. So if you ever like forget any of your exponent laws, this is what I would do. I would just expand out all of the exponents. I would just write down 12 threes, and I write down 4 threes on the denominator, and I just start crossing them out. But since I sort of want to get through as many questions as possible, we'll just use the laws. You have 3 to the power of 12 minus 4, which equals 3 to the power of 8, which is greater than 3 to the power of 7. So we have another one that works. Great. How about the next one? The next one's a bit funky because we're doing addition. We're not really sure what the value of either of these two exponents are. It's 3 to the power of 5 plus 3 to the power of 3. But I think what we can all be confident about is that 3 to the power of 3 is less than 3 to the power of 5. I think that's pretty obvious. And this is how I'm going to solve it. You could also just solve it by punching it into your calculator. That's a perfectly valid way of solving it, and it's likely faster, but this is just the way I'm going to do it if you didn't have a calculator. So I say something like 3 to the power of 5 plus 3 to the power of 3 is less than 3 to the power of 5 plus 3 to the power of 5, which is equal to 2 times 3 to the power of 5, which is less than 3 to the power of 6, which is less than 3 to the power of 7. The logic it's a bit convoluted, but I think it makes sense, right? Each of these steps kind of makes sense. We're just adding the two together, and then we're saying 2 is less than 3, and then we're saying the smaller exponent is less than the larger exponent. So we know that this value is less than 3 to the power of 7. So I'm going to put an X. Okay, next one. 3 to the power of 10 to the power of 0 to the power of 2. Again, we use our multiplication exponent law, or I guess it's nested exponents, kind of. Wait, sorry, that's not the right word. Nested isn't the right word. But we know we can just multiply the exponents, and 10 times 0 times 2, we remember anything times 0 is 0, so we get something that looks like 3 to the power of 0. Clearly that is less than 3 to the power of 7. So that one doesn't work either. All right. So 3 times 2 to the power of 6 over 2 to the power of 6. The nice thing about multiplication in an exponent is that we know the exponent distributes over the multiplication, or the multiplicands of the multiplication. This doesn't work with addition, by the way, so don't get tripped up with that. But you get something that looks like this. And we see the 2 to the power of 6 on both sides, so we can just cancel them out. But all we're left with is 3 to the power of 6, which is clearly less than 3 to the power of 7. So that one's also an X. Okay, the next one is a little bit more complicated. And I'm gonna do it in a similar way that I did with this one, where I just sort of use inequalities to prove it, I suppose. But to be honest, if you're strapped for time, just use your calculator. There's no reason to prove it per se. So I have 3 to the power of 8 minus 3 to the power of 4. I could say pretty confidently that that's greater than 3 to the power of 8 minus 3 to the power of 7, which is equal to 3 times 3 to the power of 7 minus 3 to the power of 7, which is equal to 2 times 3 to the power of 7, which is also greater than 3 to the power of 7. So inevitably, we end up with 3 to the power of 8 minus 3 to the power of 4 is greater than 3 to the power of 7. So if you just count the number of check marks, you have 3. And you guys can already see how much time that took. So to be honest, unless you're really good at using your calculator, I would recommend leaving these kinds of questions for the end. Does anyone have any questions? Yeah. Oh, okay. Alright, this is the next one.
Okay.
This one's kind of fun.
Yeah, this is a tricky one. I guess I can introduce myself, but my name's Talani, so I'll be doing a few questions. Okay, yeah. Alright. So for this one, what I did basically was I redrew it, so we have a arch like this. So the question tells us that this length is 3 meters. And it also tells us that this length is 3.6 meters. So what it's asking for is for the diameter of the arch. So if you look here, one place where we can find the diameter is if we go from the center of the circle to this point right here. And that's actually the diameter of the circle. And then from there you can see, and I'm guessing if you're in grade 9, you would know that you can use a right triangle to create that here. We have a right triangle here. So you know, I'll just make this bigger. But basically you have, this is what our triangle looks like now. We know that this side length is 3 meters. And then this side length here, we know that's gonna be 3.6 divided by 2 meters because we did it in the center of the circle. So that's 1.8 meters. And then we know this side length is gonna be our diameter. So from here, you can use your calculator and use Pythagoras theorem. So 3 squared plus 1.8 squared equals d squared. I'll just grab my calculators. 3 squared plus 1 squared. So 12.24 is equal to d squared. Then to solve for d, we just square root both sides. So d is equal to root of 12.24, which is equal to 3.49, or like 3.5. And from there we see that our question for this one is A. Does that outline kind of make sense to everyone?
It's diameter.
Oh, the diameter is 3.5.
No. You calculated the rate.
Oh, okay. So then this is tricky again because it is the diameter and then the diameter is equal to, so this should be R, sorry guys. And then so the diameter is equal to 2 times the radius. So 2R is equal to D. So we multiply 3.5 by 2. Therefore our diameter is equal to 7.0 meters, which is so Jennifer's goal is to save $1,200 each week. She saves 20% of her weekly income of $576. So what I would do for this question is I would say, okay, first I want to find out how much she saves each week. So the amount she saves each week would be 20% of 576. And if you convert 20% into a decimal, you get 0.2. So if you multiply $576 by 0.2, we can find out how much money she saves each week. So each week, if you solve that, it comes out to $115.20 each week. And so because she wants to save $1,200, what you do now is you say, okay, you want to find out how many weeks you want to do. So you do $1,200 her goal divided by the amount of money she saves each week. Or 10.4 weeks. But then because this is a little bit tricky, so because we only have whole numbers here, we don't have any decimals. So the answer is not actually gonna be 10 like it would be if we rounded it, because if it were 10 weeks, she would still need to work for 4.4 of a week to earn enough money, so the answer would actually be 11 weeks. Does that make sense? So basically, because if she were to only work for 10 weeks, she would still have to work for 0.4 of a week in order to make her goal of $1,200. And because we don't have that option here, we have to round up to 11 weeks, otherwise she wouldn't make enough. Yes.
What would be, 0.4 of a week? Just curious.
You could do 7 times 0.4, which is so 2.8 days. That makes sense. Okay. This question, I guess it's easier if you have it on paper, but basically, I think in grade 9 you guys should know how to calculate the slope of a line. So what you do to calculate the slope of a line is equal to y2 minus y1 over x2 minus x1. So rise over 1. So from that we can just take 2 points on this graph because it says it represents a linear relation, and just substitute that in for y2 and y1. So I'll just use the two furthest ones, so this one and this one. So that is equal to y2 of the first one is 13. The x coordinate at that point is 2 minus the y coordinate at the second point, which is 5, over minus the x coordinate of the second one, which is 6, minus 5 is 8, 2 minus 6 is -4, 8 divided by -4 is equal to -2, so we know that the slope is 2, so we have m, and then from here we can just calculate using the form y equals mx plus b. We know m is equal to -2, so using one of the points on the graph, we can use that to solve for b. So I'll just use the smallest one, coordinate 6, 5. So the y coordinate is 5. We already know that m is equal to -2, and the x coordinate is 6. Therefore, we know 5 is equal to -12. B, and therefore b is equal to 5 divided by -12. I'm just going to leave that as a fraction for now. Okay, and now it says, based on the linear relation shown above, when the y coordinate is 3, the x coordinate is, so we can now create a general formula for this line. So y is equal to the slope, -2 x plus b, which is -12. And now we just substitute in y and we solve for x. So 3 is equal to -2x minus 5/12. 3 plus 5/12 is equal to -2x. And then x is equal to 3 plus 5/12 divided by -2. And then from there you can put that into your calculator. I don't think it tells you how many points to put in there. -1.7, and I guess because it doesn't tell you how many decimal places to put it to, I would just assume just put in as many as the number of boxes you have, unless your teacher tells you otherwise. Does that make sense to everyone? values of 4 to the 5 and 5 to the 4 are blank because blank. So for this one, I would really quickly put it into my calculator. And so 4 to the 5 is equal to 1,024. And 5 to the 4 is equal to 625. So you can already see that they're not equal. So we can eliminate answers A and B. So why are they not equal? Is it because two powers cannot have the same value, or they cannot be written the same repeated multiplication? So when you actually expand these out into repeated multiplication, you get 4 times 4 times 4 times 4. And that's not the same repeated multiplication as 5 times 5 times 5 times 5. Therefore, using that logic, we can assume D must be the correct answer. Pardon?
Maybe we could take a break and drink.
Okay, yeah. Oh yeah, you guys can have some pizza. Yes, that's what you guys came here for.